let us start with the next entrance module of the chapter rotational motion. In this module, we are going to discuss multiple choice questions based on, oh yes, concept of torque acting on rotating body and rotational kinematics. Students, in the last module, we saw very interesting MCQs, yes or no? So, let us see what kind of question is in offer in this particular module. Are you ready? Can I start? Alright. First, let us take a look at the question. Okay, this is an interesting one. Thin uniform rod of mass 3 kg and length 2 meter starts from rest and rotates about an axis passing through its center and perpendicular to its length with a speed of 900 rpm in 10 seconds. Then torque acting on it is, okay, what are the options? Option A 3.14 Newton meter, option B 6.28 Newton meter, option C 9.42 Newton meter, and option D 12.56 Newton meter. Okay students, so what is the procedure? Yes, very good. Identify, set up, execute and evaluate. So let us move on to the solution. First step is, very good, identify the problem. So students, what's given in the question? Oh yes, I am hearing you very, very loudly. Thin uniform rod of mass 3 kg. So M is 3 kg. Very good. Then, this time also you are loud. Length of the rod is 2 meter. So L is equal to 2 meter. Then, yes, it starts from rest. So initial frequency of rotation is 0, N1 is 0. Alright. Anything else? Yes, it attains a frequency of rotation of 900 rpm. So we can say N2 is 900 rpm. Alright. Anything else? Hold on. 900 rpm. Can you convert it into RPS? Yes. What is 900 rpm? Very good students. 900 rpm is 15 rps because 900 upon 60 will give you 15 rps. Fine students. Anything else now? Yes students, see there. Time is given. T is given as 10 seconds. Okay. Any other quantities? No. What is asked students? Yes, they are asking you to find out the torque acting on this rod. So torque is asked. So, what's the formula of torque? Yes, wonderful. Torque is nothing but it is I alpha. Now students, you see here, this is a thin uniform rod and it is rotating about an axis passing through its center and perpendicular to its length. So, what will be the moment of inertia of this rod? Wonderful. So, you are revising. Yes, moment of inertia of this rod about an axis passing through its center and perpendicular to its plane is ml square by 12. Board's module. Yes or no? Fine. Now, alpha. We have N1 and N2, but alpha, how to find out alpha? Any other formula? Very good. Alpha is nothing but it is omega 2 minus omega 1 upon T. Hold on. But we have N1 and N2 then? Yes, we know one more formula. Omega is 2 pi n. Yes or no? So using all these formulas, we can find out the torque. Is that clear? Isn't it simple? Okay. Now, let us move on to the calculation part. First students, see there. Torque is I alpha. Now what is torque? See there, I is ml square by 12. So can I substitute I over there? So I will get ml square by 12. Now see here, alpha is omega 2 minus omega 1 upon T. Can I substitute it over there? So what I will get? I will get torque is equal to ml square by 12 into omega 2 minus omega 1 upon T. Now, what is omega? Omega is 2 pi n. So if I substitute the value of omega, I will get ml square by 12 into 2 pi n2 minus n1 upon T. 2 pi will be taken as common. Yes or no? Now students, after this it's very simple. Now see there, mass is given, length is given, n1, n2, T is also given. Can you substitute? Yes, if you substitute, you will get mass is 3 into length is 2, so 2 square upon 12 into 2 pi, n2 is what? N2 is 15, n1 is 0 upon T is 10. You will get this. So can you solve this students? If you solve this, you'll get the answer as torque is exactly 9.42 Newton meter. Isn't this very simple? Okay, now let me bring back the question and we need to find out which is the correct option. Yes, which option is the right one students? Option C is the correct option. Is that clear? So students, in this particular problem what we have done? We have used rotational kinematics as well as we have used torque is equal to I alpha. And remember here, the axis of that rod was passing through its center and perpendicular to its plane. Is that clear? So students, this module is the last entrance module of this chapter rotational motion. With this, we come to the end of the chapter rotational motion, and I'm damn sure that you will easily attempt all the questions of this chapter asked in the exam. Yes or no? Yes. So students, keep working. Remember this. No force of nature can stop you. Why? Because you're born to win. Rise and shine.